Here we go. Question. All right. Circles and semicircles. Here we go. Given below, gentlemen, are the graphs of two circles along with their equations. Study the graphs and equations and explain how the graph is related to the equation. You did some work with circles in geometry, correct? Some? Now, we did a lot, but it's been a little bit. You slept since then. Okay. Can you take a look at that equation and look at the graph and remember any relationships? Yeah, you got to give me something. Throw me a bone here. Come on. So how do I identify the center then? Good. Okay, if x minus 3 is equal to 0, then x is equal to 3. And if y plus 4 is equal to 0, then y is equal to negative 4. And there's your center. That's exactly right. That's where your center is. What else does that equation tell me? The radius is the square root of 16. Radius is 4. Radius is 4. Look at the second equation. What does it tell us? How is this equation different from the first equation? True. This one doesn't. This one doesn't have an x minus something, does it? So that means the x value of the center is 0. So what is the center? Center is 0, negative 2, right? Now, what's the radius? And don't tell me it's 6, because it's not. What? A little bit more than 4. What? If you'll remember, when you find all the information about a circle, the coefficient of x squared and y squared must be 1. Notice here it's 2. So we got to divide both sides by 2. So it's going to give us what? X squared plus y plus 2 quantity squared equals 18. So R is square root of 18. Can you simplify that in your head? Say again? 3, yep, 3 square roots of 2. What integer, or what two integers is square root of 18 in between? Between 4 and 5, right, because 4 squared is 16, 5 squared is 25, so it's just a little bit more than 4. And that's what you guys were able to observe from the graph. Given the equation of a circle, how much you find the center and the radius? Snap, already done. Okay, next piece. If given the equation of the circle, sketch the graph. If given the graph, find the equation in center radius form. All right. Look right here. What's the center? 3, 0. Yep, center is 3, 0. What's the radius? Radius is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. It's kind of clever how they did it exactly 5. I can make it look more like a circle if I do dashed as opposed to doing solid. It'll look like an egg if I do it solid. Now, let's take the second one here and let's write the equation. What is the center of that circle? 3, negative 1. So how am I going to write this equation? X minus 3 quantity squared plus 1 quantity squared equals, yeah, radius looks to be 4. Doing okay so far? This is memory, right? I mean, this is old stuff. You just kind of forgot a little. Never seen it before? Did you take geometry? All right. Okay. Lower left corner. Let's write the equation. What's the center? No, what's your center? -1, -3. So x, not minus 1, x plus 1 quantity squared plus y plus 3 quantity squared perfect equals 3 is the radius. Okay. Last one. What do we need to do to this last equation? Divide it by 2, so we're going to have x plus 2 quantity squared plus y plus 2 quantity squared equals 4. Center, -2, -2. Radius, 2. And there's a really bad circle. Next page. Here we go. Notice this is the equation of a circle that you're probably the most comfortable with. But I need you to know, gentlemen, that is general form of any circle, parabola, ellipse, hyperbola. That's the general form for any of them, okay? Now, what you need to remember about a circle, the coefficients of x squared and y squared have to be 1 on a circle, okay? Now, let's take a look at these instructions. If the equation of a circle is not given in center radius form, you can perform the process of completing the square to rewrite it in center radius form. So let's find the center and the radius. So this is just going to firm you up on completing the square. Let's take a look at this first one and let's figure out what the center and the radius are. Now I know you did this back in geometry. You just probably maybe didn't do it very well or didn't know exactly what you were doing. We're going to get all the terms with an x together. We're going to get all the terms with a y together. And we're going to move the constant to the other side. And we're going to complete the square. What number should go right there to complete the square on the x part? Plus 25. But if I add 25 to one side of an equation, I add it to the other side. If I'm doing it to both sides, I do the same thing to keep the teeter-totter level. If I do it all on the same side, I can only add 0. Now, how do I finish or complete the circle right here? Plus 9. Now, if I have put the right numbers in purple, and we have, then we'll be able, gentlemen, to factor into something times itself. X squared plus 10x plus 25 is x plus 5 quantity squared. And plus y squared minus 6y plus 9 factors y minus 3 quantity squared. It will have to be a circle, yes, to be a circle. Right side, what's that give me? 30. So what's the center of that circle? Negative 5, 3. What's the radius? Square root of 30. All right. Do we need to do number 2, or you want to just go on to number 3? Let's just go on number 3. If you remember, I told you that the coefficients of x and y have to be 1 on a circle. So what do we got to do? We're going to divide every term by 4. Term of x squared plus y squared plus 4x minus 1/4, oh beans, equals 0. X squared plus 4x. Well, yeah, it just kind of came out of my mouth. Equals 1/4. Complete the square. What goes here? Plus 4, gentlemen. What goes here? Do I have to put anything? Nope. Don't have to put anything. Yeah, if you want. Yep. So this is going to give me, let's see here. How's that factor? X plus 2 quantity squared, right, plus y squared. And if you want to write y plus 0 squared or y minus 0 squared, that's fine. Equals what? 17/4? 17/4. What's the center? Negative 2, 0. What is the radius? Yeah, the radius is the square root of 17 over 2. Please do not put the square root over the whole thing since we've taken the square root of the denominator. Questions? Okay. In general form, that's this form right here. Find the equation of each circle that's described below. Okay. The center of a circle is the point negative 1, 4, and a point on the circle is 2, 3. Well, all right then. Now I'm just going to tell you on these, I struggle to do this unless I plot them. So what I would do is I'd just go over to the side somewhere and I would plot negative 1, 4 and then the point 2, 3. So I've got this circle that goes sort of like that, and I'm not exactly sure how, but you got the idea, right? Now, you got to start by writing it in what they call center radius form. What's going to go in those parentheses? X plus 1 and y minus 4. How do I find the radius? Crap. I got to find the distance between those 2 points. So I got negative 1, 4, and I got 2, 3. So distance equals square root of y2 minus, x2 minus x1 squared plus 2 minus y1 squared. Negative 3 squared plus 1 squared, is that square root of 10? So what's going to go right here? Now it said to write it in general form. What do I have to do? I got to FOIL all that mess out, right? But that's okay because you know how to do it quickly because you are good. Okay, go. What's x plus 1 quantity squared? I can't hear you, Tanner. No. What do we got? Minus y squared?
Minus 8x.
Y? No. No, you said x and it's y. And then y'all finished it plus 16. Yeah, there you go. It's all right. It's all right. Now let's get this thing in standard form. It's x squared plus y squared plus 2x minus 8y plus 17 equals 10. But standard form says you've got to make it equal to 0. So what's this going to be? Plus 7 equals 0. And there is general form, standard form, whatever. Please again notice the coefficients of the x squared and the y squared are 1, and there is a plus between them. That's the definition of a circle. Let's see. The diameter of the circle has endpoints -1, 4, and 3, -8. Well, all right then. Do you guys, would it be helpful to you if you had a piece of graph paper? Anybody? -1, 4, and 3, -8. -1, 4, and 3, well, snap. Let me see if I can make that. -1, 4, and 3, -8. Okay. Now here's the deal. Those are the endpoints of a diameter. What in the world am I going to do to write the equation of a circle if all I know is the endpoints of a diameter? And what will the midpoint tell me? The center of the circle. All right, so find the midpoint. This is -1, 4, and this is 3, -8. So the center, can you do that in your head? -1 plus 3. -1 plus 3 is 2. Divided by 2 is, and 4 plus -8. 4 plus -8. Hello. -4 divided by 2 is, there's the center. Center is at 1, -2. What else do I need to know? The radius, which is the distance between the center and one of those other points. What have you got on your head? Okay, good. Let's find that distance. Notice that I didn't simplify that to 2 square roots of 10. Because in the equation, what do I have to do with it? I got to square it. Yeah. So let's write the equation in the form we know, which would be what? X minus 1 quantity squared plus y minus equals r squared. Now keep in mind that is not general. That's not general form. I lost it. There it is. That's not general form. How are we going to get it there? Yep, FOIL it. Hey, Catherine. All right, let's clean her up. Go, clean her up. What have we got? X squared. Let's go. Keep going. Perfect. So we got x squared plus y squared minus 2x plus 4y. That took care of that and that and that and that. Plus 5 equals 40. So minus 35 equals 0. There we go. So far, so good? Okay, let's take a look here. We're going to consider this equation. And we've got the graph. Let x equal 0 and solve for y. Well, let's see what the author's got in mind here. Let's let x equal 0 and solve for y. If we let x equal 0, what's that? That's 9. And solve for y. Did I do that right? Okay, so let's solve for y. What are we going to do? Square root. So I'll have y plus 4 equals plus or minus, plus or minus square root of 7. So y equals do your results make sense in terms of the graph? Well, I don't know. What have we just figured out? If x is 0, y is this. What did we just figure out? The y-intercepts. We just figured out the y-intercepts. Now, so the question is, does that make sense in terms of this picture? You got your calculator, right? Because you always get your calculator. Now, what I want you to put in your calculator is negative 4 plus the square root of 7, just on a blank screen. What's negative 4 plus square root of 7? Negative 1.3? Is that what you said? Negative 1.3 something? Is that a reasonable estimate of one of the y-intercepts? Sure is. Do negative 4 minus root 7. Negative 6.6. Okay. Is that reasonable based on your graph? Yep. Yep. So you just found the y-intercepts. No big deal. Question. Could I have FOILed this out and solved for y? How would we have done it? Y? Y? No. Y? What are we going to do with that? Subtract 7, so we'd have y squared plus 8y plus 9 equals 0. Will that factor? Not. Oh, certainly not. If it was minus 9, it would. Quadratic formula or complete the square. Complete the square. Y squared plus 8y equals negative 9. 16. Y plus 4, quantity squared equals 7. I think I've seen that before. Right there. No, I'm just saying it's another way you could have done it. No. Just reminding you that there's more than one way to do the problem. Okay. Let's look at part B. Let y equal 0 and solve for x. All right, fine. Let y equal 0 and solve for x. If y equals 0, what's that give me? 16? Oh, shoot. This is easy. X minus 3 quantity squared equals big old goose egg 0. So x minus 3 equals 0. So x equals 3. This says when y is 0, x is 3. What's that mean? How can there only be one x-intercept? Because the circle is tangent to the x-axis. Well done. Questions? You all right? We got one more question about this particular little jewel. Graph the line defined by the equation x minus y equal 3. How do we graph that? How do we graph it? So, yes? No? I added y to both sides and subtracted 3. Oh, that's linear. Y-intercept. Slope. Y-intercept -3, slope 1. Y-intercept -3, slope 1. Y-intercept -3. Yeah. Slope 1. All right. What if we had subtracted x from both sides? Does that help? Okay. At what points does the graph of the line intersect the graph of the circle? Now, if I did a slope right on this end, it would have ended up right there, wouldn't it? At what points do the graph of the line intersect the graph of the circle? -1, -4, and -1, -4. Oops. All right, so confound big. -1, -4, and 3, 0. Verify your results algebraically. How can I verify that this line and this circle intersect right there? A system of equations. Oh my gosh. A system of equations. I got y equals x minus 3. And I got, oh mercy, x minus 3 quantity squared plus y plus 4 quantity squared equals 16. System of equations. That's what I'd do. I'd do substitution. How are we going to do substitution? How are we going to do substitution? What are we going to substitute? Substitute this into the other equation everywhere you see a, right there. See what we get. X minus 3 quantity squared plus see what that gives us. That's just x plus 1 quantity squared. Did I make any mistakes? Don't think so. All right. Ready? What have we got? How do we solve that, little Jewel? What do we do? I will take out a GCF after I do what? Set it equal to 0. So 2x squared minus 4x minus 6. Now take out the GCF. And we like this one because it factors. Now the question is, are we finished? What were we looking for? At what point, yeah, I forget what we're looking for. At what points does the graph of the line intersect the graph of the circle? We found that x was 3 and negative 1. So if x is 3, what is y? 0. If x is negative 1, what is y? Negative 4. Dun, da, da, da. Those are the 2 points of intersection. There's more than one way to do things. We got one more question on this page. Let's see if we think we need to do it. We're going to read it, and you people are going to tell me if you think we need to do the problem. Gentlemen, the graph of the circle defined by that equation is pictured at right. On the grid, graph the line defined by the equation 2x plus 3y equals negative 6. You can do that. Then algebraically find the points where the line intersects the circle. How would we do that? Another system of equations, just like we did the last one. Do we need to go through that problem? Then we're going to skip it. If you feel like it's something you need, the notes are posted. I'm really going to try to get you out of here with as little homework as possible. I promise. So, all right, let's take a look. We're on the last page of the notes, correct? No, snap, almost. All right, well, let's see what we need to do here. The graph of the circle x squared plus y squared equals 7 is pictured to the right. On the grid, graph the line defined by the equation x plus 2y equals 8. Then algebraically find the points where the line intersects the circle. Why do I feel like we've done that before? All right, here we go. On the grid, graph the line defined by the equation x squared, or x plus 2y equals 8. How are we going to get that into a form we can graph it? Good. So we got y equals negative 1/2 x plus 4. Plus 4. You know, it's funny. Every time I hear people yapping in this class today, it's been gentlemen's voices. I don't know why. I'm just saying. Either I screwed up or these two pictures don't intersect. That's a good question. That's why we're going to do it. All right. How do we prove this algebraically? Well, we're going to do a system of equations again. The system of equations will be this equation plus this equation. I would again do substitution. So I'm going to have x squared plus y squared equals 7. All right. Let's get your brain going. Let's multiply that out. X squared plus. What's negative 1/2 x times negative 1/2 x? 1/4 x squared. Remember your middle term? Middle term is this times this, doubled. So that's negative 2x, double it. Well, I don't know where this is going exactly. Let's see. X squared plus 1/4 x squared. What's 1 plus 1/4? 5/4. Oh, mercy. We got to go to quadratic formula with that bad boy. Here we go. X equals negative b plus or minus square root of b squared minus 4a. Oh, that'll cancel. That'll work. C all over 2a. Ah, that ain't so bad. 4 plus or minus all over. Now what's nice, look right here. Dun, 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 right? Yeah, exactly. Yes. So it's 16 minus what? 45. And 16 minus 45 is imaginary. Therefore, no real solutions. You don't have to go through and work this all out with I. You can stop right there because your discriminant's negative. There are no real solutions. Bottom line is, those don't intersect. So that's how we proved it algebraically. This system of equations has no real solutions. Okay? You doing all right? Okay. We got one more thing to talk about, and it's the graph of a semicircle. Now, if you go back and look at the graph of a circle, you know that the graph of a circle is not a function. Because does not pass the what? Vertical line test. Horizontal is for 1 to 1. Does not pass the vertical line test. So we know that that thing's not a function. Now I want you to take a look at this one. Consider that equation. Solve the equation for y in terms of x. That means make it say y equals. You should get two different equations. Well, let's see if we do. We want to make that thing say y equals. So we're going to have y minus 2 quantities squared equals 9 minus x plus 3 quantities squared. Square root both sides. I got two equations. Ladies and gentlemen, each of those equations alone is a function. 2 plus square root of that stuff is the top half of the circle. Did I mess up?
No. So when you square root, it's like you're trying to get rid of the squared on the y minus 2.
Yep.
So since the 9 minus x plus 3 squared is together, you wouldn't cancel out the squared?
No, because it's the square root of the whole mess. Yeah. Are you okay that you got two equations sitting here? 2 plus square root, that's going to be the top half of the equation of the circle. 2 minus the square root is going to be the bottom half of the circle. Separately, they are functions. Together, they are not a function. Okay. Now, if you look right here, here, you got this, right? I got to erase because I write too big. It says graph the two equations you got using two different colors. Well, I didn't give you two different colors. Let's graph the whole function over here. What's the circle? What's the circle? What's the center? Negative 3, 2. What's the radius? Radius is 3. 1, 2, 3. 1, 2, 3. Negative 3. I don't have a center line over here. 1, 2, 3. Negative 3, 2. 1, 2, 3. 1, 2, 3. The 2 plus is going to be that one. And the 2 minus, oh, that's really bad. Well, stint it. Let's try that again, because the radius is 3, right? 1, 2, 3. 1, 2, 3. That's just about as bad, isn't it? So when we made this thing say y equals, we were able to see two different functions. Now there's one more piece that I want you to look at. What if we had taken that? Well, all right. Well, Armando sakes. Now, okay, so your last question. Since this slacker isn't there, we're just going to change it right here because it's the same thing, except it's asking us to do what? Solve for x in terms of y. This is the very last one, but the last page isn't on here. Now, we already had the graph of the circle, negative 3, 2, 3, 1, 2, 3. Let me get this back in here because I'm a slacker and I erased it all and it's right there. Let's solve that for x in terms of y. And again, that means make it say x equals. Questions? Got to do it right. That's an awesome question. What is the difference between this one and the last one? Now, we solved it for x. We didn't solve it for y. It's right and left, not top and bottom. Now, here's what we're going to do. Here's what we're going to do. Let's pick a point that I know is on that curve. Are you okay that 0, 2 is on that curve? So let's let y equal 2. Now when y equals 2, now we know what x is, but just pretend you don't. When y is 2, this is the square root of 9 minus, when y is 2, 0. Negative 3 plus or minus 3. Now, here's the deal. If I do the positive one, negative 3 plus 3, okay, I'm going to get, if I do the negative 3 minus 3, I'm going to get, you with me? So bottom line is if I do the positive one, I'm going to get this half. If I do the negative one, I'm going to get this half. So making it y equals breaks it into two functions, top half, bottom half. X equals, does that break it into two functions? Is my purple half and my blue half here, are they each functions? Do they pass the vertical line test? No. So this gives you a left half and a right half, but neither one of those are functions. That is why you cannot put x equals into your calculator when you're in function mode. That's why it's only y equals. All right. What have we done in this lesson that you need to make sure you remember? Go back and look through your notes. Is there anything we've done in this lesson that you think, I have got to make sure to remember that? Distance formula? What? What? Say again? What points are actually negative? Oh, that the points when you do x minus when in the formula, you got to do the opposite. Got to remember the midpoint formula. The center radius formula. What else? Discriminant, you mean? Good. If your discriminant is negative when you're trying to solve a system of equations, then there are no real solutions, so the graphs do not intersect. The general form. And in the general form, what's the coefficient of x squared and y squared? 1. Yep. Complete the square. Yeah, complete the square. You've got, what, 15 minutes or so? I'm going to give you homework time. And I hope you have a wonderful Thanksgiving with your family.